Okay, in a problem like this, it's always good to read the problem through a couple times, then probably start drawing a sketch. So here's town A, here's town B over here, and they're 542 and a half kilometers apart. Joey starts at town A headed toward town B at this rate, 75 kilometers per hour, and Ross starts B at the same time headed this way at 80 kilometers per hour. Since Ross is going faster, he's going to have traveled farther when they meet. Hopefully, they're not going to have a head on collision. And we're going to use this formula right here. Both are traveling t hours when they meet because they left at the same time. So if distance equals rate times time, Joey's distance, could call that d sub j if I wanted to, is his rate times however many hours they're traveling. And Ross's, I'm sorry, Joey's distance is 75 times t, and Ross's distance is his rate times the number of hours. And what has to be true is that the sum of those distances is 542 and a half kilometers because they're covering the distance between the two cities when they finally meet each other on the highway. And one way to do this problem is to try to get it down to one variable by substituting these values in for d sub 1 and d sub 2. So 75t plus 80t equals that total distance. If we solve that for t, we get 542 and a half divided by 155, which up here we can see that's 3.5. That's hours. That's time. But that's not what they're asking for. They're asking for Joey's distance. So we have to substitute the time that they traveled into the formula for Joey's distance, which is 75t. And there's the distance that Joey travels. If we multiply 80 times 3.5, we'll get Ross's distance. And it's guaranteed that that distance plus this distance is going to add up to 542.5. Okay, there you go. Hope that gave you some idea how to proceed in problems like this. If you have any questions, post a comment.